All right, guys, well, let's get started here. So today we're going to look at what we call transformations of the quadratic equation. So yesterday we were introduced to the vertex form of the quadratic relation, which was y equals a bracket x minus h squared plus k. And I'm going to just, ask out loud, and you guys are going to answer to yourselves. Maybe you're at a dining room table, maybe you're alone in a bedroom, but you're going to tell me what a, h, and k represent in our vertex form equation.
A dog.
Okay, so A, remember that is the direction of opening. It also tells us about the width of the parabola. H and K give us the coordinates of our vertex. And remember, we're going to have to switch the sign of H because of that negative sign. So if we look at our base parabola or our parent function, everything we're going to talk about with transformations compares to this base parabola. All right? So everything refers back to that. We're going to go through an investigation together on how you can transform a quadratic equation, but first we need our base parabola, our parent function, y equals x squared. So right now, reading from this equation, y equals x squared, what is the vertex? And you might be saying, it's not in vertex form, but it is. It is in standard form, it's in vertex form, it's also in factored form right now, because this is the most basic parabola. So if vertex form is a times x minus h squared plus k, but this is the actual equation, well, that must mean that h and k are 0. So the vertex is at 0, 0. I'm going to plot that right there. The axis of symmetry, remember that's x equals h, so x equals 0. The direction of opening, a is a positive value, it's positive 1, so it opens up. And let's, that's going to be positive 1, make a table of values here with these x values, and I'd like you to be doing this as well, and fill in the y. So if y is equal to x squared, well, that would be equal to negative 2 squared, which is 4. Take a moment and fill in the rest of this. So just a note for anyone who wasn't in on the lesson yesterday, if at any point you have a question, you can choose to unmute your mic and ask me the question, or type it into the chat box, and I do have that up so I can see it. If you don't want your camera visible on the recording of this when I post for the rest of our class, turn your camera off. That's all I've got to say there. But it is nice having all of you guys here. I hope that you find the live lessons useful, and thank you for showing up. That'd be 1, 0, 1, 4, and 9. And I'm going to plot these points, and you are as well. And I see my lovely base parabola like so. Ta-da! We're going to explore what's called the step pattern. I'm going to make myself wait for 1 minute for you guys to get this sketched out. Okay, so every parabola will follow a step pattern. And For a typical parabola or the base parabola, we're going to take a look. When we, from the vertex, go over 1 to the next point, we go up 1. That's over 1, up 1. And that's true in either direction from the vertex, like so. So then from the next point, we go over 1. On either direction, if you go over 1, how many steps do you go up? It's 1, 2, 3. Fill in the next step in this pattern. It's over 1 and up how many? Correct. It's 5. So when we're moving from the vertex on our base parabola, this is when A equals 1. So from the vertex, I go over 1, up 1, over 1, up 3. And that gives me a quick way to plot the graph. And this is really going to pay off in a few minutes. So just remember that step pattern. Keep it in your mind. Flip the page. We don't need any of this graphing calculator instructions. We're going to go on to vertex form of a parabola and do a little investigation together. We are given an equation slightly different than the one we just worked with. For the sake of time, guys, maybe keep this table handy, because here, this is y equals x squared. This is y equals x squared plus 2. So if I fill in, I'm going to go -3, -2, -1, 0, 1, 2, 3. Well, if I know x squared from the previous one, I'm just going to add 2. And 11. There's my table of values. Take a moment and plot the graph, please. Okay. 2, 4, 6, 8, 10, 12. There's -3 and 11. -2 and 6. -1 and 3. 0 and 2. This red parabola, I'm just putting our basic parabola on there for us. Okay, y equals x squared. So tell me, maybe throw in the comments, what are the coordinates of the vertex for the parabola modeled by y equals x squared plus 2? Yeah, good job, guys. So the coordinates are 0 and 2. And we can all agree it opens up, right? So what changed? What changed from our base parabola of y equals x squared to this parabola of y equals x squared plus 2? The width didn't change. It didn't move horizontally. It just moved up 2 units. Every point, almost threw my pen across the room, every point on our base parabola, my sketch is a little off, just moved up 2 units. Interesting connection to this part of our equation, which is the only thing that changed. Let's keep that in mind. Okay, this time we have y equals x squared minus 3. Fill out a table of values for me, please. And sketch it out. I'm going to draw my base parabola. And I'll draw this parabola. One and negative 2, negative 1 and negative 2, 2 and 1, negative 2 and 1, 3 and 6, negative 3 and 6. Notice that I'm putting arrows at the end of my parabola tails because they go on forever. That's y equals x squared minus 3. Okay, so my vertex here is 0 and negative 3. It still opens up. In the chat, write a comment telling me what changed. Okay, what transformation happened to our base parabola to turn it into y equals x squared minus 3? What happened to every single point on that parabola? Yeah, it was lower 3 units. Is there a connection to the equation, do you think? Can you connect that to a certain part of the equation that we're given? K is negative 3. Amazing. Thank you, Kendra. Okay, Kendra, Anna, Morgan, you all got it right with the the parabola being shifted down 3 units. Kendra pointed out, well, the K value in our equation is negative 3. And that's the connection. So when we say transformations to parabola, we're going to use a couple key terminologies. So all that's happened here is we have a vertical translation. We're going to use the word translation 3 units down. That is the transformation that happened from y equals x squared to become y equals x squared minus 3. Jot that, and then we're going to move on in, I don't know, 15 seconds. This is tricky without seeing you guys in person. There's a printing error on mine. Parabola investigation number 3 lost the table of values. I'm fine going right to parabola investigation number 4. So let's flip the page and move on to that one. 3 and 4 are the same type of transformation. So I'm not concerned that we're gonna all of a sudden lose out. Okay, slight difference here. We don't have a K value, but we do have an H value. Y equals x plus 1 squared. Before doing a table of values, before graphing, tell me what the vertex of this equation will be. So really tell you what the H value and the K values are. All right, you guys are right. The K value is 0. It's missing, so it's 0. but we have to be careful here with this sign. Remember that when we're pulling h out of the equation, we switch the sign. So whoever said -1 and 0 is correct. If you said 1 and 0, you just missed that tiny little step. Okay, so fill in the rest of the table of values, please. And then graph. I'm going to graph our parent function. I'm just using the step pattern: over 1, up 1, over 1, up 3, over 1, up 5. Sometimes I can't count to 5. All right, so I've got 0 and -1 and 0 is my vertex. My A value is the same. My step pattern stays the same, but I've also got these table of values I can use. So 1, 4, that's 4, that's 9, and that's 9. So we can see that this parabola still opens up. But what's changed? Tell me what transformation applied to our parabola of y equals x plus 1 squared that makes it different from y equals x squared. Tell me in the chat. Every point, yeah, every point has moved 1 to the left. Okay, so we're going to call this, now is this moving vertically still? No, it's a horizontal translation. One unit left. And what is that going to be related to in our equation? A, H, or K? It's about our H value. H, 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 H. You guys are right. Okay, we're going to consolidate this now. I'm just going to move up to my little blank spot here. So we had a K value. K values gave us the vertical translation, right? So if K was a positive number, if it was above 0, did it translate, do a vertical translation up or down? Ah, good. When K is a negative number, what direction was the vertical translation? Down. Okay, H. This is our horizontal translation. Now, when H is greater than 0, what direction does it translate? Yeah, it's going to go to the right. We need to be careful. We need to switch the sign from the equation. So if it's positive in the equation, it means H is actually negative. So H in the vertex, when you look at the vertex, if H is positive, you shift to the right. If H is negative, you shift to the left. We're going to come back to to this in 1 second. We're going to move on and look at some transformations involving A. I'm going to move this in 15 seconds. Okay. Parabola investigation number 5. What's different here? Our A value. In the chat, tell me what the vertex is going to be, what the H and K values are going to be for this equation. As I draw our parent function, over 1 up 1, over 1 up 3, over 1 up 5. Yeah, our H and K values are 0. So our vertex is at 0 and 0. Nice work, folks. Let's fill in the rest of our table of values. Okay, I'm gonna plot these. Now, this transformation needs to look back at our step pattern. So remember that on our base parabola, we go over 1, up 1, over 1, up 3, over 1, up 5. Here, though, we went over 1, up 2, over 1, up 6, over 1, up 10. Oh, my camera's frozen. Okay, I'm going to reopen it. Give me a second. Can you guys see that again? Can someone send me a message in the chat just letting me know if you can see the graph? Yes, you're awesome. Okay. So here we see that our step pattern is now over 1, up 2, over 1, up 6, over 1, up 10. If our parent function is a step pattern of 1, 3, 5, how have our step patterns changed? They doubled. How does that relate to our equation? Okay, if everything's being multiplied by 2, oh my goodness, our A value is 2. So what do we call this? This is our vertical stretch. We say vertical stretch by a factor of 2. That's our transformation here. Go ahead and work through investigation number 6, please. start off, figure out what the vertex is. H and K are 0. So again, 0, 0. However, A is negative now. So what direction does that parabola open? Down is correct. Okay, figure out our Y values, please. Oh boy. 2, 4, 8, 10, negative 12. This is a narrow parabola. Okay, so what has happened? What changes happened to our parent graph, our parent parabola, to turn into this one? There's actually two transformations this time. You can give me one of them. A became negative. Yes, Kendra. So what happened to our parabola? Instead of opening up, it opens down. We call that a vertical reflection. So we'll say reflection. Now the terminology we use here is about, or you might see it as across, or you might see it as on the x-axis. Okay, so that flip, it means that our parent parabola has been flipped or reflected about the x-axis. And Anna, nice job, vertical stretch. Now we're going to ignore the sign here because the sign tells us about the reflection. But I love that you said vertical stretch by a factor of 3. Good use of terminology. And if we look at our step pattern, that's over 1, down 3. The original, it is snowing so much outside right now. Okay, over 1, up 1 is our parent. Over 1, down 3 is this one. Over 1, down 3 would be the next, but we've actually gone down 9 because we are multiplying our step pattern by 3. So here are our 2 transformations. 2 graphs to go, guys. We got this. If you've got this copied out, flip it over. Okay, start the next one. Parabola investigation number 7. So there is no H and K value, which means they both have a value of 0. If there's no A value, what is the actual value of A? When previously we saw one that was something like, I don't know, y equals x minus 2 squared. Yeah, remember if it's being multiplied and invisible, it's actually a 1. That's just a little question for you guys. And it's going to open up. So figure those out, please. Over 1 up 1, over 1 up 3, over 1 up 5. Fractions. Oh, your favorite. Your very favorite. Great. So I'm going to graph these. Maybe you prefer to convert them to decimals when you're graphing. That's fine. If you're doing a question, though, I want you to give me the answer in fraction, please, unless it's money. All right, so this is over 1. Okay, 1, 1/2, 1 1/2. 1, 2, 3, 4, 4 1/2. There's y equals 1 over 2 x squared. Take a look at our step pattern. Oh, geez, I've done one wrong in here. That's 2. Right there. Sorry, guys. Okay, so a step pattern. We went up by 0.5, then 1.5, then that is then 2.5. Compared to our regular step pattern of 1, 3, 5, what happened? What happened to our step pattern here? Here's 1/2 x squared. That's x squared. It's divided by 2. That matches our a value here of 1/2. So my transformation, I still call it a vertical stretch. I know it looks like a compression. This is going to make more sense in grade 11 when you start talking about actual compression factors. We're just keeping it the same terminology as much as we can for grade 10. So vertical stretch by a factor of whatever a is. In this case, that's 1/2. Okay, take 5 minutes and try our last parabola together. Let's plot it. Going by quarters this time. Once you've got it, you have two transformations to describe for this parabola. See what you can get. Yep, nice, Kendra. Vertical stretch by a factor of 1/4. And there's the other one, vertical reflection about the x-axis. Nice work. Before we wrap this up, we're going to go back to our little consolidation section and talk about A, and then we're basically done for today. I'll leave this up for 30 more seconds. We're going to go back to this section right here. And parabola investigation number 3 that we didn't do because my printing got messed up. So what does A tell us? A tells us two things. One is vertical reflection about the x-axis. Okay, remember that's if A is negative. The other thing that A tells us is vertical stretch factor. So we're going to leave that here for today. You guys have the next section, which is part 2 of transformations. I would really like you to try yourself. I've already posted a video of me walking through it, but flex your brain muscles, all right? See what you can get done there first. Refer to the video. Even if you wanted to challenge yourself, watch that section, pause. Try the next section, watch it, pause. That works too. What you have to do for the rest of the week, you have a Desmos assignment. Okay, go and complete some marble slides. It's a pretty fun one. I like it a lot. And I'm not saying that in a math teacher way. It's a pretty fun game. You also have some knowledge hook activities to practice on. You have a practice quiz, and then you have your final quiz, which is due by Sunday evening. So Grace right now is asking, what about number 3? Are you asking about parabola investigation number 3, Grace? Yeah, my sheet didn't print it out properly. It's very similar to investigation number 4. It probably just had a negative value in there, like x minus something. So go ahead and work on that if you want, but we've covered what that would do, okay? Awesome. So I'm going to be on here for another 10. Is the practice quiz worth marks? No, it is just that. It's practice so that you can see what are you getting, what are you struggling with. So I really suggest you try that before our videos. I have video drop-in hours tomorrow and Friday. Try it before that. That way you know If you're not understanding something, you can ask us to ask for help. If it's after that, you can post in the discussion. I'll take a look, but it's easier to explain in person with the document camera than it is typing up. All right, so this officially ends the lesson for today. If you're feeling good and want to go try your textbook homework, go for it. If you want to keep the Zoom on for the next 10 minutes while you work in case you have a question, then go ahead and do that. Okay, thanks for stopping in today, guys. And we will talk to you again later.